Hello, this is Information Service Engineering, lecture number 4, Linked Data Engineering. In this part of the lecture, we are going to see the second part of the web ontology language, OOL. So let's start. In the previous part of the lecture, we saw how to define simple classes and assign individuals to those classes. In this one, we are going to deal with the complex classes. And one of the categories here is the nominals. Nominals are also called closed classes, are the classes that you explicitly define what are the individuals that they can host or classify, let's say, and you cannot add a new individual after the definition. So let's see how they work. Here in this example, we have defined the class novel and then two instances of this class, Animal Farm and 1984. And then we go and we define a new class, which is called Novels in Store. You see here it's type of class. And we want to define it as being a nominal. So how do we do it? Using the property all one of. So by that we say that, explicitly say that novels in store, this class will contain only one of the following individuals, Animal Farm or 1984. Another way to create complex classes is by using logical class constructors. Logical class constructors are applied to create complex class descriptions from atomic classes. And they are the following. We have the logical AND, which we can use, which is translated to the all intersection of. The logical OR, which is translated to the all union of. And the logical negation, which is translated to the all complement of. And let's see how each one works with real examples. We start with the intersection. We see here in our example that we have a class book and another class things in store. And then we define a new class books in store, being of course a class, and we say that all intersection of things in store and book. So what does it mean is that the new class that we created, the books in store, results from the intersection of the individuals of the classes things in store and book. So this is how we deal with the intersection. And let's continue with the union. So here we have a class book, of course type of class, and in order to make a union, we do it in the following way. We say that is all equivalent class, all union, and then we list all those classes that we want to make the union using them. So in the end, we will say that novels, poetry, and non-fiction are also books because we said that they're equivalent to the class book. And let's move to the negation, which we achieve it by using the property all complement of. So here we have a class book again, and what we say is like it's RDFS subclass of complement of writer. And what do we achieve? This is semantically equivalent assertion to what we've seen also before in the previous part of the lecture, to the statement that book, which is a class, is disjoint with writer. And let's move to the property restrictions. So there are also all property restrictions used to describe a complex class. Those restrictions might be based on values, which is the all has value, the all values from, and all some values from. And also we can have restrictions based on the cardinality, like by using the properties all cardinality, all mean cardinality, and all max cardinality. And let's see examples for all of them so that we understand how they work and use them in all. We start with the has value, which is the one that introduces, we restrict based on constants. So what do we want to do here? We want to create a class which is called Orel's books. And what do we want to say? That we want to explicitly state that this class we will contain books that they are authored by George Orwell. And in order to do that, we will use the all has value constraint by using a constant, where the constant in this case is George Orwell. So in order to do it, we define first the class and then we say it is RDFS subclass of Then we use the all restriction. The all restriction will be on property author, and then we say that this has value George Orwell, and this is a constant here. And we move to the all values from, which is also a restriction with a strict binding. So we want to create a class poetry, and in order to create this class poetry, the restriction we want to have here is that the authors here, they are all poets. So to do that, we start by defining the class poetry, and we say this is subclass of. We define that of type restriction on a certain property. This property is the author, and all values from poet. So the all values from property fixes all instances of a specific class C. In this case is the class poet, to have to us allowed range for a property P. The property P for us is author now. And this is a string binding because all values should come from this class, not some values. So let's see the graph form of this example so that we make it clear. We want to create the class poetry. In order to put an instance in this class poetry so that it has type of poetry, the author of the instance should be a poet. This is a strict binding, and this is how it will look like. But we also have loose binding, and the loose binding is achieved by using the property all some values from. So here we want to define a class reader, and to be a member of this class reader, you should read some books, but not necessarily only books. That means loose binding. So to do that, you see, we first define the class reader, and we say it's RDFS subclass of. We define it's of type restriction in a specific property, the property reads, and then we say all some values from book. So this is the loose binding here. So some values from describes that there must exist some individuals, but not every individual of the property P, reads in our case, and they have fixed range to the class C, which is a book for us here. And this is how the graph would look like here so that we understand. We want to make some instances being of class having as type the class reader. And we see here that Harold is can be a type reader since he reads Animals Farm, which is of a type book. So it qualifies to be a reader. Doesn't matter if he reads also other stuff that they are newspaper, for example, as we have here. Since here we have a loose binding. Some values, they should come from book, but not all values. And we move to restrictions with cardinalities, where we have three properties here for cardinality restriction. The all cardinality, which restricts to an exact number. The all minimum cardinality, which restricts to an upper bound, and the maximum cardinality, which restricts to a lower bound. And let's see an example for that. Let's say that we want to create a class which is called tetralogy, and in this class, whatever is there should have 4 volumes. So the cardinality of this property should be 4, and this is how we do it. First, we define the class. We say RDF subclass of. It's of a type restriction. The restriction is on a certain property, has volumes, and the cardinality of this property should be 4. And let's play a bit around. So let's say that we want to define a class vegetarian. How would you define it? As a strict binding or loose binding? I would say it should be a strict binding. And here is how we define it. Because if you are a vegetarian, you are only vegetarian. You should not eat something that is not a vegetarian food. You don't want that. So it's a strict binding, and this is how we do it. You see that we define a class, vegetarian, it's a subclass of. We put the restriction there on the property eats, and then you see the property all values from. This is already the sign that we have a strict binding, because all the values should have this specific range. And then we have the all complement of animal, which denotes the negation, should not be of an animal. And let's see another example. So I want to define the class driver. What should it be? So I would say that it's probably a loose binding, because can be somebody who drives a car or who drives a bike. It's a loose binding. And exactly, this is exactly how we do it here. You see that we define the class driver. It's a RDF subclass of, and then we put the restriction there on a certain property, which is the property drives. And then it comes the property all some values from, and not all values from. So it's already a sign that we have a loose binding, some values from car. So for us, a driver is somebody who drives a car, but not only a car. So the same person can also drive a bike. That doesn't matter. Still is a driver for us according to this definition. So to summarize, we've seen this slide before. We said that all DL is based on description logics. We saw already some of the properties of description logics we can achieve by all. And well, go ahead and try to play around and see how you can achieve more things there. So in the next part of the lectures, we are going to see how to query RDF with Sparkle.